Welcome to CATS Tutorials, and in this video I'll be doing practice problem 12.4. We're given a positive sequence and our connection is a delta, and the impedance per phase is 18 plus J12 ohms, and we're given a line current of 19.202. So what we know for a delta-delta connection is that the phase, so it has to find the phase current AB as well as the phase voltage AB. So the phase voltage is equal to the line voltage for a delta connection, and the line current, so the line current lags the corresponding phase current by 30 degrees. So that is what we know about the delta-delta connection. So now let's see what we can do. We know that the line current is equal to square root of 3 multiplied by the amplitude or the magnitude of our phase current, and the angle is 30 degrees less, right? So given this line current over here, so you can take this, 19.202 to be this part here, which is square root of 3 IP, where IP is the magnitude of the corresponding phase current, which is IAB. So you can take this IP to be the magnitude of that. So we can find IP by saying 19.202 divided by square root of 3, which will be the magnitude of IAB, and the value of that magnitude will be 11.09. And we said that the line current lags the phase current by 30 degrees, which means this angle of this line current over here is 30 degrees less than the current of this phase current. So to complete our solution for IAB, we know that the magnitude is 11.09 and the angle is 30 degrees more because this one actually lags. This lags by 30 degrees. So the angle of the phase current is 30 degrees more than this, which is 65 degrees. And that is our answer for the first part of the question, which was asking for the phase current IAB. Now to find the phase voltage VAB, we can use this formula. We know that the phase current is equal to the phase voltage divided by the impedance delta or delta impedance. We now have IAB and we're given this impedance in the question. So you can say VAB is equal to IAB multiplied by Z delta, and we just basically substitute 11.09, that is, with an angle of 65 degrees multiplied by this impedance, which is given to us in the question as that value. After computing this, or after just putting this into your calculator, you should expect a VAB of 239.9 with an angle of 98.69 degrees in volts, which is quite similar, which is quite close to the 240 which is given in the textbook. And that is how you basically solve this problem. If you like this video, just go ahead and give it a thumbs up. And if you haven't subscribed, please subscribe.